Hello, everybody. My name is Michael Schultz. I'm working at the Institute of Logistics and Aviation at TU Dresden in Germany. Today, I want to talk about airport performance monitoring using ADS-B data. On this topic, I work together with Stanley, Xavier, Enrico, and Rainer. Let me briefly introduce myself. I studied business and engineering, and in 2010 I finished my habilitation about passenger dynamics in airport terminals. And 1 year ago I finished my habilitation in the topic of aviation as well. I was 10 years research assistant at TU Dresden. After this, I was moving for 5 years to the German Aerospace Center, the Institute of Flight Guidance in Braunschweig, and I was heading the air transportation department. With finishing my habilitation, I moved back to Dresden and now I'm principal investigator, and at the same time I'm visiting researcher at the NTU Singapore at the ATMRI, the Air Traffic Management Research Institute. My research topic, besides passenger dynamics, are more or less the data-driven and model-based approaches. It's a very generic topic, but a lot of further research I was dealing with agents and their behavior, and now I try to learn a little bit more from data, what happens and how we can use this knowledge which we gain from the data in the airport operations and the airspace management in particular. When starting working with data, I gained some experience from the data expert. They are finding so many inefficiencies in the aviation systems. I just want to give you a very short example. When I was trying to head into Singapore airport last February, you can see that the aircraft is going in two different kind of holdings. Then there was one landing approach. The landing was not finished. We take a second attempt and then the aircraft is landed. When you go for data analytics, you will see that these holding, yes, true, some inefficient in terms of we are not going directly into, but this is nothing you learn from data. This is given in by the expert. These holdings are mandatory in operational procedures. So what we try to do, and I think all the participants in this conference will do the same, we are trying to somehow combine our domain knowledges with the data we see. When you look at the Single European Sky ATM research program, you will see there were a lot of solutions provided to improve the aviation system. With a specific focus on the airport operation management, and this is the point we would like to address when we talk about airport performance, you will see that there are some specific solutions available, and this is also true for the integrated arrival departure management or the integrated surface management. But finally, as we know, the airport, it's not only the airport itself, but it's connected to the whole aviation network. In our research, we focus on the airport itself, and the argument for this is very easy from my point of view. So if you look at the data we provided here, it comes from the performance review report. You may see that if an aircraft will start at the airport and we measure the departure time, you will see that there's a big chance that this is somehow delayed against the schedule. And we see there's a high standard deviation in this. That means that there is a given level of uncertainty. And this is much more higher than the en route or the flight phase. So we are dealing with 20 minutes, or I would say roughly say 17 minutes, and we have 5 minutes here. And then if we only have 5 minutes in all the phases, it means when the aircraft is started, even start rolling, we can somehow predict at a given level with less uncertainty when the aircraft will arrive on the next airport. So when you really want to go for improvements, from my perspective, you should somehow deal with the airport itself. So furthermore, and you see the numbers, honestly, yeah, you know it's pre-COVID time. So but you see that the punctuality of flights decreases over the years, year by year. When you think of airport operations and airport performance, you easily come to the point that airport will be impacted by weather, by local weather events. In the first analysis, we try to understand how weather impacts the local performance, and therefore we measure the delay happens on the airport, and we try to analyze how the weather directly impacts these delay. There is a approach from Eurocontrol called the UpMap approach, and the UpMap tried to quantify local weather information derived from metadata in numbers, and these numbers getting higher if the weather is getting worse or impact the airport operations more. And as an input, you can see on the left side the temperature, the dew point, the wind direction and speed, and the humidity and pressure. These are major impact factors for the 5 categories, which we'll describe here. These categories in the UpMap approach are visibility, wind, precipitation, freezing condition, and dangerous events. And what you can see here, derived from our paper in 2018, is from London Gatwick, the first 60 days of 2014. And here you can see dangerous events, just thing like thunderstorm or heavy rain conditions are very prominent, and this comes with at some days with freezing condition and some windy condition as well. And normally you see for the UpMap, if per day the UpMap coefficient is higher than 1.5, you will talk about bad weather. And as you can see here, some bad weather days. So having that in mind, here on the left side, you can see how a weather impact occurs in the morning. This was a 2-hour period of fog, and this impacts even the operations 2 hours later. This one was followed by a delayed operation in 1 or 2 hours, and even some movements are going down. And this get more prominent, the effect of weather in the airport operations. You can see here was a heavy thunderstorm, at least for 4 hours in the London Gatwick scenario. And here you can see that lots of movement have to be shifted, even cancelled, and then you see that the system recovers after 3-4 hours with much of delayed operations. So many aircraft stand on the ground and have to somehow restart, and here was another period. And so here you can see this kind of typical behavior. There was the initial impact, and then you see the consequences in a window of 1, 2, 3, 4 hours. It depends how heavy the impact was. After these initial analysis of the airport performance, we're asking ourselves, okay, is there a chance that we can somehow learn the airport environment more in detail, or if we learn more from data? So when you go for the airport surrounding, you can use some CAD plans, or you go to OpenStreetMap, and then somehow you will find the airport layout. This is a very easy example of London Gatwick. Here you can see 2 runways. One is in operational use. The other is just for operation when the main runway is not into operation. So London Gatwick has one of the most used runways in the world with nearly 56 or 57 movements per hour. And the idea was, can we learn from data how the airport looks like, how the airport is operated? And I think the pretty easy thing is just use all the positional data from ADS-B and try to find out how the airport looks like. And it's easy task, so even if you have some deviations in the position information, you will finally get the layout itself. Just bringing all the points to the ground, and then you see, okay, somehow an airport appears. And then you can see on this data how the airport will be operated by aircraft. So you can see, for example, the aircraft started at a given position, then there was a pushback, and then the aircraft is going back to the runway system, and then the aircraft is finally start, or the other way around. You have the same for landing, taxi operations, and going back. And the very first thought was to seeing this. First of all, you learn the structure, and then you learn how the structure is operated. So after a while, you recognize which runway is in use, which runway will be used, how aircraft can taxi to this runway, where the queues are positioned, and something like that. And finally, we showed in one of our papers already that you can somehow identify some operational hotspots. And from this, you can somehow create a network of operations, and then you can see, okay, an aircraft is even able to move from one of these yellow points you can see here on the right side, and it moves from here to here. And then you can finally have a network. When you recognize that you can rebuild the airport environment just by positional data, you ask yourself, okay, who will be benefit from this? And there's an easy and simple answer. This system is called like an airport collaborative decision making, the A-CDM. And there are so many stakeholders involved in this kind of system. So you can see here on this overview, somehow Eurocontrol as a network manager is interested to get informed how the airport will perform, at least in actual times or in somehow predicted times, the next 1 or 2 or 3 hours, to somehow manage the European network. The local airliners wants to know if there's a chance that they can depart or arrive on time. You have the ground handlers, you have the airport itself. So many stakeholders somehow want to provide data or use the data for their own operation. Not only researchers recognize that you can use the data in operational context, also the airport knows, and there's a need for a digitization to allow to implement innovative approaches in current operations. But as you can see, there's the airports and the stakeholders on the airports differ in terms of size, of status, of constraints, or even of business model. So the idea will be that there always are local rules, local levels of collaboration or information sharing, and each stakeholder has to take out its own benefit for this. So in an operational environment, you have to make sure that if you share data, that there is somehow a balanced system of sharing data and get benefits out of it. So when you look at the airport system, you see, for example, that the air navigation service providers can provide some estimate arrival times. The apron control can provide landing times. The airport operator itself can provide some data for stand and gate allocation. The ground handler can provide some planning data. Information concerning the de-icing processes could be provided, and the airliner itself could provide some flight plans and other flights related data. So if you're putting all these data together, then the stakeholders can combine these knowledge, these data, and try to extract some good decisions. Some kind of standard will be provided by the airport collaborative decision-making process. Here, some milestones are provided to describe an aircraft trajectory by timestamp. As you can see here, there will be 16 timestamps defined. So this one allows you to describe an aircraft movement by time. So for example, here you can see 3 hours before the aircraft lands, the flight plan will be activated. The flight enters our flight information region. Here the aircraft is landed. The aircraft is in blocks, so the aircraft turnaround can start. Even passenger processes are somehow covered by this, and the aircraft is leaving the airport. Having this in mind, you can derive some controlling process, and here you can see, for example, the target off-block time is set. Then you can go for unimpeded taxi time. You will see, okay, if this happens, then you can estimate the takeoff time. Depending on the current runway operations, you get a target takeoff time, and then it will be calculated backwards by a variable taxi time dealing with the current operation, and this gives you the target startup approval time. So at this timestamp, the pilot will ask to get a startup approval, and then the aircraft will go directly to the runway and can make a takeoff. And as you can see here, if the target takeoff time somehow exceeds this target startup approval time, then a recalculation has to be done. So this is the normal process of A-CDM, and we want to take this idea and manage our processes with A-CDM milestones. In previous talks, we heard there are a lot of information in the ADS-B messages we can use to contain some information that will be latitude, longitude, positional data, flight plan related data, aircraft related data. And in an initial analysis, we try to find out what is the update rate within our airport environment. And as you can see here, we receive updates every 10 seconds with 66%, which is pretty fair, and therefore we can use it for our airport operations as well. So in our proof of concept, we use the data from Open Sky Network, and we use Zurich environment because a lot of the receivers are around Zurich, and these receivers allows us to give a good insight into Zurich airport operations, and we have to deal with all the problems the community has. So for example, we have some offset in our data, so there is no GPS signal available, or we have some missing points that somehow not all the points available even for the ground operation, so we have to deal or refill the data. From the data available, we try to provide the necessary timestamps for the A-CDM milestones. So some of them was easy to detect. For example, landing or takeoff, you just see that the height is changing from a given level, and you see some climb or descent values, so you can easily take this. For in-block and off-blocks, getting a little bit more complicated, but finally, as you can see on the right side, around each position, you will see that the positional data are somehow jumping, but you can detect if these are going out of this or coming into this, and then you can assume that the aircraft is now in the pushback phase, and then you can say, okay, the aircraft already has an off-block given or somehow reaches the en-block. With this table, I would like to show that we are able to somehow reproduce some of the A-CDM milestones. Here you see the numbers. We bring in some new milestones, for example, the runway exit. This allows us to define the runway occupancy time, for example, the time between the landing and the runway exit, and we can somehow provide some taxi data as well. And with this, you can see we have new milestones, and we can describe the aircraft operations at the airport. If you apply these milestones to actual operations at Zurich Airport, you have here the air view. So the aircraft is in the landing phase, on the final, and finally it leaves our airport area. And here you can see the landing time, the runway exit. It goes to the position, it goes out, and it restarts. Furthermore, we can use data reduction techniques to simplify trajectory, and this comes with a nice effect that if you simplify your trajectory, you will get prominent points out of your trajectory, and these you can transfer into operational hotspot. And you can see here they are very prominent when you're crossing runways or when you have some stopping points. Besides the operational hotspot, you can see here that we can cluster ground operations as well as the arrival traffic into Zurich Airport. And this is for us more prominent, not to know the deviations in positions, as you can see here for the yellow one, but more important for us, the deviation in time. So when an aircraft is arriving the airport area, we're asking us, okay, entering here, here, and here, how long does it take until the aircraft is landed? And this can be used for prediction of airport operations and airport performance. So here you can see that we can even derive runway occupancy time for a specific runway setup, or even taxi times for different kind of runway uses. So for us, the next step will be that we try to cooperate with airport to somehow bring in our ideas of using the ADS-B data to describe current operational environment and help the airport to improve. At the given stage, we can somehow use our data for monitoring, but for the next step, we want to enhance our clustering algorithms, and we want to allow for prediction of milestones. And finally, we want to make sure that even small airports can use this for current operation, and therefore, and in this context, we think that the network manager will also benefit from this kind of information. I would like to thank you for your time. I hope you got an idea how we would tackle the problem of airport performance monitoring using ADS-B data. Please, if you have any questions, don't hesitate to contact me. Thank you.